So I want to show that tangent theta is equals to 3 over a at p. Okay, so I don't have the line equate with the equation y equals to ax, and a is positive lah, so it meant to tell you that the line must slope this way and not downwards. Okay, it meets c at the origin and at the point p. So I want to show that tangent theta equals to 3 over a at the point p. Well, what do we know about this p? If first we see that it satisfies both equations, right? So definitely one way to look at this is to solve them simultaneously to observe what we can find about our p. No, at y equals to ax, we can actually replace this because it lies on the curve. Right, this is equals to 3 sine square theta cos theta, and we can replace our x with sine cube theta. Right, then with that 3 sine square theta cos theta is equals to a sine cube theta. Let's simplify this further. You can actually get that your 3 over a is equals to sine theta over cosine theta. I'll leave you to do the simplifying, okay? Then 3 over a is the same as the tangent theta. And yeah, so you can see that we are done. So we're done with the first part. I want to find a value of a such that the line passes through the maximum point of c. Remember that we want the point c, right? And remember at the maximum point, right, one trait that we know is that tangent theta, right, is equals to square root 2. Okay, so this is not to forget from the earlier lah. This is from earlier. If you forgot this, go and watch my video from earlier parts. Okay, so basically that means I want 3 over a to be equals to square root 2. Right, and then just a is equals to 3 over square root 2, or you can write it as 3 square root 2 over 2.